inequalities. Inequalities are very much like equations, except I'm not saying that something is equal to something. I'm saying it's either greater than something else or less than something else. Or in this case, I'm saying negative 2x plus 6 is greater than or equal to x plus 30. The solution to an inequality, for that reason, is not just one answer, but it's usually an infinite number of answers. Your solution to your inequality is often going to be, for example, something you can express on a number line. It's going to be, greater than some value, or greater than or equal to some value, or less than some value. So your answers to inequalities is going to be an infinite number of answers. All right, so let's try to solve this. It's like an equation in that we get our x's isolated. We get them all on one side. All right? Doesn't really matter what side you gather things on. I think I'm just going to bring that guy over here for fun. So let's add 2x to both sides. There we go. So I have 6 left over here, positive 6, is greater than or equal to x plus 2x is 3x plus 30. Since my x's are on the right, I'm going to bring my other numbers to the left-hand side. Again, keeping my equation balanced. So I have 3x. You have to make sure you keep that going in the right direction. Let's see, 6 minus 30, that is a negative 24. I'm doing my calculations correctly. X is almost by itself. Let's get rid of that 3. 3 is multiplied by x, so I can divide by 3 to get x isolated. Negative 24 divided by 3 is a negative 8. There we go. That, I'd say, is my solution set. It's a solution set because that's an infinite number of numbers that make this true. Any x that's less than or equal to negative 8, when I plug this in, will make this true. Now, it's a little funny because I have the x on the other side. So let's just see how that would work. If I do put the x on the left-hand side, you just have to remember the x is by the little pointy side, so the little pointy side has to stay with that x. That's equivalent to that. I just flipped the whole shebang. Does that make sense? So now, we usually express our solution to an inequality on a number line just to really be obvious about the fact that my x can be anything less than or equal to negative 8. So if 0 is here, negative 8 is smaller than 0, right? So let's see, it's less than or equal to. The or equal to means I fill in that circle because it can equal negative 8. And less than means I have to go towards smaller numbers, like negative 10, negative 12, and so on. So if I were to plug in negative 8 or negative 9 or negative 10.7 or negative 1,000,000.1 into this original inequality, you would in fact get something bigger on this left-hand side and something smaller on the right-hand side. Isn't that kind of fun? So I solved that inequality. I'm stating the solution, and I'm writing it as a number line. Hey, let's state the solution using our cool interval notation. You remember that stuff? So let's write this. It's going from, negative infinity. Do you remember this? Soft parentheses, negative infinity, all the way up to negative 8, and it's including negative 8, so I'm doing a hard bracket. So I could write my solution like this as an inequality, or I could write it using my cool interval notation. That looks pretty fancy. I'm impressed by that. How are we? Are we good? Now I want to alert you to something. If I had solved this a different way, then I have to remember something sneaky about inequalities. So I'm just going to back up. Let's pretend that instead of that over there for now. Let's pretend that instead of solving this the way I solved it, I had decided to bring my x's over on this side. Okay? Let's say instead I decided to subtract x. So this would be negative 3x plus 6. That would have been fine to do also, right? Isn't that okay? Then I would have subtracted 6. Negative 3x is greater than or equal to 24. This is all legal. Divide by negative 3, because I want to get rid of the negative 3's. Negative 3 divided by negative 3 is 1. Divide by negative 3. Then I would get x is greater than or equal to negative 8. And then I'd say, oh, hold on, that's not what I got doing it the other way. What the heck happened? What did I forget to do over here? Ah, that's right. Look, whenever you multiply or divide by a negative number, you have to remember that the inequality symbol reverses. You have to switch the inequality sign. I'll just write it. Switch the inequality sign. All right? So here I'm dividing by negative 3. That means that greater than or equal to becomes a less than or equal to. We've talked about this in class, and it makes sense. If you multiply a number by a negative number, a really big number now suddenly becomes a super small number. Like 100 is a really big number, but a negative 100 is a super small number. So the whole relationship of what's bigger and smaller flip-flops. So if you're ever in a situation where you're dividing by a negative number or multiplying by a negative number, you have to remember that that inequality switches direction. Hey, am I safe now? I have the same solution that I got doing it the other way. Okay? So that's good to know. I just want to talk about one other kind of inequality, and that's two inequalities combined into one. All right? Let's just do one more. These look weird at first, but it's really just taking two inequalities and smushing them into one. For example, if I had 3x plus 1 is less than 16, and let's write it over here, and 3x plus 1 is greater than 7. Those are two inequalities. Well, I'm talking about 3x plus 1, so can I just combine those into one and say, oh, 3x plus 1 is less than 16, and 3x plus 1 is greater than 7. Remember, the big mouth stays with the thing at 5, the little pointy stays. So I just combined two inequalities into one. So it's an inequality with kind of three sides, if you will. So if I say solve this inequality, again, I'm looking for the x values that make this true. I'm looking for the x values that will turn this into some number that's bigger than 7 and less than 16. All right. Again, an infinite number of x's will work, but it's going to be limited somehow. So let's find out what my solution set will be. I just approach this the way I'd solve any inequality. I get x by itself. So let's look here. 3 times x plus 1. Let's work from the outside in. Let's get rid of that plus 1 first. That's usually the easiest way to go. So now I have three sides, basically. So if I'm subtracting 1 from there, I have to subtract 1 from here and subtract 1 from here. You see how that works? All right, I have 3x by itself in the middle. 7 minus 1 is 6. 16 minus 1 is 15. So far, so good? X is not isolated yet. I'm going to isolate it by dividing by 3. And of course, whatever I do to that, I have to do to all the other pieces of the inequality. 6 divided by 3 is 2, is less than. This gives me a 1x, or x, is less than. Oh, heck, there's my solution set, right there. That's kind of nifty. That means if I plug in anything bigger than 2.000000001, anything like 3, 3.5, 4, pi works, 4.999999999 works, 5 doesn't work. If I plug in any of those x's into this equation, I will get, into this inequality, I will get a true statement. So this is my solution. That's my solution set, is what we sometimes call it. 2 is less than x, which is less than 5. Or x is greater than 2 and less than 5. We like putting this on the number line. Zeros there. There's 2, 3, 4, 5. It's an open circle because it doesn't include 2. My solution set does not include 2. It includes everything bigger than 2 and up to, but not including 5. Hey, should we be fancy and use our interval notation? We could also write it soft parentheses 2, because it's starting at 2 but not including 2. We say that's non-inclusive, comma, up to 5, not including 5. So that's using our interval notation. That means all the numbers between 2 and 5 work. Here, let's just check this for fun. Let's just do a quick check. Let's just try something. Give me a number between 2 and 5. 3. Very good. All right. Let's check if x equals 3. Does this work? All right, let's try. 7 is less than 3 times, okay, I'm substituting in a 3 for x. Let's see, 7 is less than, 3 times 3 is 9, plus 1 is 10. Oh, is 10 between 7 and 16? Yeah, it works. 3.1 would work. 4.5 would work. I'm not going to check every number because, wow, even if I had an infinite amount of time, I would not be able to check all of the numbers because there is an infinite number of numbers in there. Rational numbers, irrational numbers. All right, that's how you solve this kind of inequality. Okie dokie, I hope you had fun watching this.